In this video, we're going to take a look at some of the tools that are included in OpenBridge for reinforcement of your structure. And those are the ProConcrete tools specifically. So why ProConcrete and ProStructures? Well, complex structures are everywhere, and 2D plans don't always do them justice. Folks will spend a lot of time studying those plans, trying to understand the designer's intent, when a 3D model is probably going to show that much easier. Plus, hey, we live in a 3D world. There's BIM and there's BRIM. That 3D model is our single source of truth for the structure, and we can generate drawings and reports from that 3D reinforcement and also do conflict detection much earlier in the project as well. So as we kind of begin this transition from 2D plans to 3D models and 3D detailing, we understand that plans are still submitted on the vast majority of projects out there. Very few model-based contracts yet, or model as a deliverable. So we still need to generate lots of views from that 3D model, plan views, elevation views, section views, detail views. And using the ProStructure tools, we can generate some intelligent annotation on the reinforcement in those drawings, so that if the model changes, the drawings are updated automatically as well. So that 3D model is driving any changes on the sheets. And at the end of the day, the bar list and bending charts are just a very simple output of the overall process there. Now keep in mind, we are using a common data environment here. All of the OpenX products are all based on the very same MicroStation platform. Here's just a few examples of some of the modeling that can take place with the ProConcrete tools included in OpenBridge Modeler. And when I say included, we have all of the bar placement tools included in your OpenBridge license today, but you can also enable a full ProStructures license while in an OpenBridge Modeler session. And that allows you access to all of the tools in both ProConcrete and ProSteel. Now, there are some concrete placement tools in ProConcrete, and if you've not started actively modeling structures yet, you will need MicroStation solids for placement of the reinforcement. It's all placed relative to those faces with the cover that you specify. So let's take a look at how we can generate some basic footings, columns, and a cap with these tools. So the first one I've opened up here is the pad footing tool. I'm going to give it some dimensions here for the length, the width, and the depth. I selected it by 1 point, so I just indicate a point here in the model and it will generate that 3D solid for me. And then similarly, there's tools there for columns and beams as well. So with the column tool, I could pick a rectangular or circular column shape, give it a diameter, and then again, it can be done in a variety of ways. I've chosen to do this by 2 points. So I'm going to snap to the bottom and top of each line here to generate that cylindrical shape. And then reset out. Accept the columns and then go ahead and add the beam to my model. So here's that, also by a rectangular shape. I give it the dimensions of that rectangular shape. Again, I'm going to do this by 2 points. It was along the bottom of that beam shape. And now we can go about reinforcing those shapes. Now these are, again, all of the bar placement tools, whether it's the parametric tools that are listed here, the non-parametric tools, or the face-based rebar. All of those are included with your OpenBridge license today. We don't need a separate ProConcrete or ProStructures license to access any of those. So let's work through each of these tools and how they could be used on a bridge model today. Okay, first up here, I'm going to use the ProConcrete tools that are included here with OpenBridge Modeler. I'm going to go to the pad footing reinforcement tool and select that. Now with this tool, we can specify covers off the top, bottom, and side of the faces here. And then when you specify the reinforcement, you can either give us an exact number of bars in each direction, or you can give us a spacing. You'll notice here for the top, I did a 5 bars in each direction. On the bottom, I told it a 1 foot spacing. So that's why we see the differences between the top and bottom mats of reinforcement here. You can also optionally enable side reinforcement here as a, let's say, a type of stirrup to kind of hold all of this in place while the concrete's being poured. Now what I'm going to do is I'm going to just do a quick measurement here using really the place line command, just snapping to the reinforcement here, and I can see that it's was roughly about 2 foot 10 to 11 inches in length. That if I were to extend that bar down, it would meet the bottom mat of reinforcement. So I'm going to give it a tail dimension here of 2 foot 10, so it comes down almost to the bottom here in both directions. On the main reinforcement tab, I could have also enabled a U-bar option there that would have given us a very similar effect. We can also change for the ends of any of the bars here. We can put a bend on the bars. We can add hooks to them. You could put a crank in the bars if you needed, 90-degree hooks, 135s, 180. They're all a potential option here for you to use to define what we call an end condition on each and every bar. Now, since it knows this is a pad footing, it assumes there's a column above it. So it gives us the option here of adding some dowels or starter bars for the column. So here I'm going to tell it I'm going to do 15 number 10 bars. And you'll notice when I select the bar size here, the embedment depth and extension values are automatically calculated. So I'm going to select the pad, select the column, and now those starter bars have been placed here in the model. So we can kind of take a look at those. You can see them from the top view and the isometric or view and or front view here. Notice we also see like 3 sets of stirrups there holding all of this in place as well. So if we go back to here, these are what we call our template ties. And so relative to the base of the column, I've got 3 sets of those added in there as well. Now that I'm happy with what I have defined for the first footing and column combination, I can identify any others. I can clone that reinforcement over to those others very easily. So next up, let's take a look at the reinforcement for the column itself. So we'll select the column reinforcement tool. First thing I usually do when I open this is go ahead and select this icon and select a column shape. From there, it's simply wanting to know, do we have a rectangular or circular column? And then from there, we can start doing our reinforcement. So initially, you'll notice I only have a few bars in there, but I select that top icon and it uses this V1 bar, my vertical bars, for all 15 of those. So I now have 15 number 10s going up. They're at a 0 offset relative to the bottom of the column. They're stopping right at the bottom of the column, but they are going on up 2 foot into the cap. So we can see the starter bars there adjacent to all the other bars here in the model. Now in the lap options, we can define a methodology there for it to figure out how long to lap them and what our stock length is. And then in the ties, you'll notice we can do circular or spiral ties very easily. We can set spacings for those. You can have one zone, like I have here with a 6-inch spacing, but you could also potentially have multiple zones of reinforcement here as well. And if you needed to nudge all the bars one way or the other, you do have some offset options. You can also define the lap of that reinforcement as well. Again, once we're happy with what we have, we can clone that to any other columns in our model here as well. Now keep in mind, if we were doing this with an actual OpenBridge model pier that we had referenced into a drawing here, then if we went back to OpenBridge model, or if we went to the file that had the bridge model in it, and we made changes to either the lengths of the columns or the cover or elevation on the top of the footing there that forced a change in the column length, the next time we come into this reinforcement model, it would update all that reinforcement automatically. It wouldn't take any other effort on our part to do that. So next we'll take a look at reinforcing this beam cap. So I'm going to select the beam reinforcement tool. I select the first icon, the icon in the middle of those three, and that will generate some reinforcement, some default reinforcement in the top and bottom of the cap, as well as a stirrup arrangement that I had previously defined. And we can see by looking at it in this front view, there's 3 different spacings of reinforcement here. We've got a little tighter set of stirrups at each end of the cap, and then a little more spread out over the middle part of the cap there. We can also see we've got pairs of bars along the top and bottom of this cap. And so let's take a look at how all those are defined. So on the beam defaults, these are all of our clearances or covers off of various faces here. And any change we make here would quickly update any of the reinforcement here as well. Now for the longitudinal reinforcement running along the top and bottom of the cap, you'll notice I have several different zones of bars here. I have 4 different zones of bars, yet only 3 different sets of reinforcement data. The bottom bars are identical for both the zones, so I only need 1 set of reinforcement data for that. In the lap options here, I could define a lap for the bars if I needed to, and a stock length. And then for the stirrups, you'll notice I have 4 sets of stirrups here at the moment. So I'm going to delete out 2 of those sets and then add them back in. So I've added in 2 more sets here. I'm going to name them just the same thing I had before, but I want you to see how you define which bars the stirrups are relative to. So I'm going to put a 90-degree bend on one end, a 135-degree hook on the other, and then you simply left click out here in this window, and that's how you define where that particular stirrup begins and ends. So initially here I've got a 3-legged stirrup, and then I'm going to go define the S4 stirrup I'm going to use the same two end conditions here, and then I will start and end that stirrup right there. Okay. As far as the assignment tab goes, that's where we can define the level all this reinforcement's going on and other attributes of that reinforcement. So let's look at doing a, let's say, a retaining wall type example here. We'll open the continuous footing tool, and I'm going to ask it to place a 3D solid shape for the footing on this retaining wall. I simply select the line and accept it to generate that solid. And then there's one here for the wall panel itself. So I'll give it a height and thickness for this wall panel. Tell it how I'm going to position this. And then I'm going to select that line again. And accept it. And now it's placed that microstation solid for me to represent the wall panel. So let's go in and add reinforcement to this in the next video. For the footing, instead of using the pad footing tool this time, we're going to use the continuous footing tool. It's similar, but does have some different options here. So we can add top and or bottom reinforcement to this. You define your longitudinal and transverse reinforcement as opposed to long way, short way in the other tool. But essentially you're still going to give it some bar sizes and either a number of bars or a spacing for the longitudinal bars. For the transverse bars, they're always defined by spacing here. And then you tell us how to do the layout. Do you want us to round down or round up or center the bars? How is it you want those done? Most of the time, round up's probably going to be the most common method for you here, but it doesn't have to be. So right now, I'm just going to tell it to place the bars straight in each direction, but we'll come back and take a look at that type option here in just a moment. So there's our initial mat of reinforcement in the longitudinal and transverse direction. But here for the top set of bars, if I turn on U-bar, you very quickly see the change there in the view on the right side of the screen. And if I change it from a U-bar on the bottom to a closed option, now it has more of a stirrup type look to those transverse bars there. We can still change any end conditions or tail conditions here, or add mechanical devices if we needed to any of these. All the same options in each tool, so it makes it pretty easy to follow along. So next up here is the wall panel itself. So let's take a look at the wall tool here. And we could have either a single rebar mat in that wall that's centered within the concrete there, or if we turn on the far rebar set, now we're going to have a mat of reinforcement along the front and back of this wall. So I'm going to go in and set the spacing for all of this. I give it a select the concrete face, and very quickly it's modeled all of that reinforcement here. You have options for which bars are on the outside versus the inside relative to those concrete faces. So you can flip those as well. You can add end conditions to these. You can set your stock lengths on these. We can change the levels for the near and far reinforcement. And we can also even set a direction on these bars. Now initially they come up relative to our shape there, but you can give it basically 2 points and define a line and say, okay, I want all my reinforcement relative to this line. and define the direction for that final reinforcement there. All right, so those are all the parametric tools. Let's take a look at some of the other rebar set tools here that we have. So next up, we're going to take a look at an abutment. This is one from our typical training that we do. This is from our precast bridge wizard tool. So I've copied that abutment into the view here, but you'll notice it kind of falls in line with everything else here, especially when I'm trying to look at it from the left or right side. So what I'm going to do is I'm going to use a tool. I'm going to go in and select that abutment cap, hold down my right mouse button and pick display set. And what that tells the software is show me only that element here in the model, regardless of my view orientation, and any new elements that I add. So as I add reinforcement, I'll be able to see all of that as well. Now for this, what I'm going to do is I'm going to place, or I'm going to use the continuous footing reinforcement tool for this abutment seat. But first thing I want to do is I want to measure. I need to know how high is that seat right there, or how high is the back wall on this abutment here. And if I measure it, I'm going to come down, snap, and this is a little over 7 feet in height. So what I'm going to do is I'm going to change my top clearance here from 2 inches to, let's say, 7 feet 3 inches. And that's going to keep that reinforcement within the seat area of my abutment here. So I'm going to define some longitudinal and transverse reinforcement for this seat. We can look at it there. And this looks very similar to what we just placed a moment ago at the bottom of that retaining wall footing. So I'm going to probably just keep everything that we have here and accept this. Now for the back wall, here's the thing. We can't use another parametric tool on this one solid. All right, if these were 2 separate solids, we could use a parametric tool on each one. But because I've already used the continuous footing tool for the seat here, I'm going to need to use the single rebar set to define the reinforcement in the back wall. So first thing I did is I used the extract faces and edges tool here, and I extracted that entire face. And what that did is basically just created a closed shape all the way around the perimeter of that face right there. So now what I'm going to do is I'm going to move that in 2 inches. I'm going to move that shape in 2 inches relative to this concrete face here. And I'm going to use that red dashed line to define where my reinforcement goes in the back wall. So I'm going to insert this using a defined polyline, or in this case a closed microstation shape here. So I'll select that shape, and there's my single rebar set, basically a mat of reinforcement in here. Now right now it's sticking out behind the wall here, so I just need to change my offset here to move it inside of that wall. And then the other thing I want to do is I want to flip the X and Y bars here by changing this radio option button right here. So now we can see that resulting reinforcement in there. But if I look at it in the plan view, this top bar, I only have it running a portion of the length here, and I want that to run the full length. So I'm going to change my end offset for that and move it down. Instead of about 6 inches from the top, I moved it down about 8 inches from the top. So that was able to give me a full bar across the top here. And now I'm going to change my start offset to a little over 4 feet so that the first bar starts within the limits of the back wall. I didn't really need any additional set of those bars here in the abutment seat. So we can see what that resulting reinforcement looks like. I'll go ahead and turn on the bars in the X direction there. And then I'm going to shorten this one up about 1 inch. I had a 3-inch cover previously. Right now this one's defaulting to 2 inches here. So I'm going to add a 1-inch offset here to raise that up just slightly. Now that that reinforcement looks the way I want it, I want an exact copy of that, a mirrored copy essentially, on the front face of this back wall. So what I'm going to do is just use element selection. I'm going to select that reinforcement and that closed shape. I need both. And then I'm just going to copy it over to the front. So I'll pick the copy command. I'll snap to what was there. I'll snap to the front face, hit the letter O on my keyboard for origin snap. I'm going to move back, use AccuDraw until I want to go back 2 inches and place that reinforcement in there. And now to make changes to it, I just use the element selection tool to double click to it. And then I can change my vertical offset here and the direction of the reinforcement as far as which bar is closest to that front face. So now that I have both mats of reinforcement and we've generated the view that we want here, kind of take a look at it real quick. See that that looks like exactly what we were shooting for the reinforcement in that abutment. Next up here, we'll take a look at adding reinforcement to a barrier. So I've copied in a barrier from a bridge model that we also use in our training class. So I've used the display set tool to go in and isolate this barrier. And now what I need to do is I need to go in and draw, using the Smart Line tool, just place a 3D line that represents the outline of the reinforcement. So we can kind of see what this barrier looks like in a couple of different views here. And I'm going to rotate this around so that I'm looking at it a little more straight on here from the end. And again, what I want to do is I'm just going to use the Place Smart Line tool to go in and add a 3D line, a rough 3D line initially to this model, and then we'll go in and modify it after the fact. So I'm going to go in and snap to this point here, try and come straight down with that line. And then I'll use the modify tool to go in and raise this or modify this line both straight up, but I also want to modify it and pull it in a couple inches from each face here as well. Now, if you already had drawn somewhere else, it doesn't have to be exactly here. You could draw this precise shape that you want really anywhere and then place it here relative to, let's say, the end of the barrier. And that's really all we need for our single rebar distribution here in a moment, to go in and add all of the bars to this barrier. So I'm going to use this simple 3D shape that I've created here. I'm going to use the concrete overlay tool to add an overlay element around this barrier, and I'm going to name it barrier to that reference. And then we'll use the extract faces and edges tool one more time, and I'm going to extract an edge off of the barrier. It doesn't really matter which point I pick here. I'm just going to arbitrarily select an edge from this and accept it. And now I have a 3D linear element which is going to be used as a path for this single rebar distribution tool here in just a moment. So I'm going to tell it I'm going to place these bars at a 1 foot spacing. I'll go out and select my barrier shape here. I'm going to select the bar that's going to be used for the shape, and then I'm going to select the path for that. Now initially I've messed up a little bit, so I'm going to change this transform option here to none. I didn't really need to transform it. I didn't need to move that reinforcement relative to that line. And now we can see that we have some reinforcement roughly following the shape of that 3D line that I generated before. And it will always honor that shape right there. So if I were to come in here and modify this 3D smart line, I could come in here with the extend element or extend line tool and maybe project it down 3 to 6 inches down into my concrete deck. When I do that, all the reinforcement that was modeled relative to that line changes as well. So we can see that it's updated all of the bars here relative to that one 3D shape. Okay. Next tool or last tool we'll take a look at here is for modeling of reinforcement in the deck. Now you think sometimes a rectangular deck might be one of the easier things, or even this kind of parallelogram shape here, but it's not. We have the crown of the deck coming into play. We have the longitudinal slope of the deck coming into play. So a lot of the times you're going to end up using a tool called irregular dispatch to model this reinforcement. And with the irregular dispatch tool, essentially we're going to need 2 or more 3D lines to help us tell the software precisely where the reinforcement begins and ends, and also potentially passes through. So this is, think of this as a line representing where the center line of all these bars are going to be located, and we'll see that here in a moment. So what I did is I just placed a smart line along the top of the deck there, and moved it down a couple of inches, and now I've moved it forward into the deck a couple of inches. So I'm setting essentially the exact starting location for the top set of longitudinal reinforcement in the deck. So now what I'm going to do is I'm going to extend this just a little bit, actually kind of de-extend it a couple inches in from the end. I want to kind of use that to help set a cover off of the end or transverse end of the decks here as well. So now that I've generated this 3D line and I have the first one placed where I want, I'm going to copy this, and you could do this and place it at multiple locations along the deck, as many as you need. I'm going to do it at the midpoint and at the end of the deck in my case. So I'm going to tell it I want to copy that 3D line right there. I'm going to pick my midpoint snap, and I'll snap to the middle of the deck, and then I will snap to the end of the deck. And then once I get that placed, in both instances I'll need to move it down a couple of inches. And then for the end one, again, I'll want to move it in a couple of inches. So first we'll select the middle one here and simply go in with the move command and tell it we want to move this vertically down 2 inches. And accept it. And again, AccuDraw is your best friend here. It's going to make this a very simple process here. Now for this bar, again, I need to, or for this line, I need to move it down 2 inches, and then we'll also have to move it in 2 inches from the end of the deck. So we can see that it's moved down. We'll come back to the top view. And actually it's located properly there as well already. So let's take a look at how do we go about using these three lines to place our top mat of reinforcement here. So again, we're going to use this irregular dispatch tool. I'm going to select a bar size and grade, tell it I'm going to do a certain spacing, so I'm going to just very simply set this to a 1 foot spacing. I don't need to change any offsets, I've taken care of that myself. And then I'm going to go out and select those three lines. 1, 2, 3. And that quickly it's added all that reinforcement to my model. If we zoom in really close, and it's kind of hard to see, but you'll see some little circles there where it crosses that middle line there. And what I'm going to do is I'm going to right click and pick that middle line and say make that an arc instead of a point. Basically, instead of it being a kinked line, kind of smooth it out to have a more of an arc type shape there. So there's our resulting reinforcement. At any time we could go in and change the spacing on that reinforcement. So here I've made it an 8-inch spacing, and we can see it added quite a few more bars there. And in the rebar modification set of tools, we have a lap splice rebar tool where we can go in and select any set of reinforcement out there. We can set a stock length, set a lap method. We could either do bar diameter times some value or give it a fixed distance or put in a mechanical device in there. And then we can tell it or ask it to go generate all of those splices out there for us. So here it is, but all of our splices there just a moment ago all lined up. They weren't staggered at all. So we can go in and ask it to stagger these for every other bar. So here I've set a stagger of 2.5 feet for all that reinforcement. Okay, so that was kind of a quick look at probably the most common tools you'll use for various parts of your structure. So now let's take a look at, once you have the reinforcement modeled, what can we do with it, and what are the next steps? So first up here, we're going to take a look at the positioning tool, and this is also included with your OpenBridge license today. So with this concrete positioning tool here, what we can do is go in and assign bar marks to all of our bars at this point. None of that's happened yet. We're going to ask it to recognize our bar shapes, whatever we want to use for bar shapes. We can ask it to go ahead and mark all of our straight bars and straight variable length bars. You can create a macro on how to go about naming all the bars, and that's all really well documented. And then we just go out and we ask it to process, and in my case I'm going to ask it to process all the bars in the model here. It comes up with some initial results of some bars that it found out there in the model. It runs the calculations there, and it comes back with and identified and matched up shapes on all these bars. So I've double clicked on a bar here, and it's showing me, if we call this a shape 2, it was using one set of dimensions, but it could be a shape 17 or several other shapes there that have a same three-legged bar to them. I can pick the one I want, accept it, and now all my bars have marks. You'll notice if I hover over a bar now, it knows the size, the mark, the spacing, the length, all the basic attributes of that bar are now pop-ups. But if you want or need to, there is a manual marking tool. Once you've run the positioning process, you can use this manual bar mark manager to quickly go in and rename any of the bars that you have positioned. So what I can do here is I can go in and select any of the sets of bars here. So I've grouped these by concrete name here. So I can go in here and modify this character, and instead of this being a bar being an 11A1, I'm saying I want this to be an 11B1. And I'm going to do that for all of these bars right here. I'm going to select all of those, right click in the user mark column, tell it I want to modify the alpha character and change it to a different letter. I'll do the same here for these footing bars here. Change these over to an F, and we can repeat that process for any of the other bars here in the model. Then we select apply bar marks and have it update the model. So now it knows about the marks that it generated, but it also knows about how we renamed those same bars. And then in bar analytics, we can go in and look at the number and weight of the bars, how many, all the different bar marks that are out there and their sizes, diameters, and shapes. Again, the number of bars and all the other statistics related to these bars. And again, all of those are included with your OpenBridge Modeler license today. Now next up, we'll take a look at the drawing production tools.
Sorry, I didn't get that. Please sign in.
So here we are in kind of a elevation view for this pier, or we can switch this around to a right or a top view. I'm going to do this from a top view. This is the easiest way I was shown to generate, let's say, an elevation view of this pier and see all this reinforcement. So I'm going to let it generate the height of the view from the view. Place the section call out here, give this a name, let it create a drawing model and or a sheet model of this, and then I'm going to change the scale of this as well. I'm going to try about a 3/8 of an inch per foot scale for this. Once I have this all filled out and select OK, I'll kick off that process and it will go out there and create the save view, create the drawing model, reference the save view to the drawing model, create the sheet model, reference the drawing model to the sheet model, and along the way it also annotated and kind of redisplayed all of the reinforcement as well. So here we can see the results of that. So we can see there are some labels that were automatically generated, and those are configurable in a DGN library for various things that you would generate drawings for. It can kind of auto annotate a lot of the stuff out here, and if you need to make changes to those, you simply click and hold down and move these labels anywhere you want, and it will retain those locations for any changes that you make in the future. And then we can also turn off some of this reinforcement. Some of the dash line stuff here is stuff that we're seeing from that forward view. There are bars that were re-symbolized along the way, but we don't have to stick with or retain that re-symbolization. And we can also turn off some of that stuff here from the reference model as well. So I can turn off all of that other than the concrete faces, and probably end up with what I want to see here, both in this model and in the resulting sheet model as well. Because whatever it looks like here, that's what I want to see in the sheet model. And again, if you modify or make changes to the reinforcement in the 3D model, of course that's going to update what we see here, both the re-symbolized bars, but also the labels as well. So we can use this main bar defaults here for, let's say, our bar ranges to tell the software whether or not to show us all the bars or individual bars, how to handle the longitudinal bars versus our bar ranges. And you can also just double click on any bar here and make changes to them as well as far as how they look. I'm going to ask it to go through and update all of the re-symbolized reinforcement here and change the way that looked based on my rebar defaults over there. But again, any one of these bars you could double click on and change as well. So now when we come into this view, the only thing we might need to turn off here is some of that resymbolized or the forward view reinforcement we were seeing in the model there. I'm going to turn on much of that, but turn off everything but the concrete faces in this view right here. So now that much more closely resembles what we had there in the drawing model. And this is certainly a very powerful set of tools to be able to go in and re-symbolize all this reinforcement and generate your views. So here I'm going to use section callout, strike a line up above the cap here, and then pull down, and that's going to give me a plan view of the cap. So I'm going to ask it to go ahead and create the drawing model for that at the same scale, and then it will go in and show us all that reinforcement for the plan view of the cap that we would also need to include in our drawings here as well. And again, worst case, you probably just need to move a few labels around here, but everything else is already going to be labeled and dimensioned for you. And if you want to change any of these, you simply double click on them and you can start editing and making changes to the labels on this reinforcement or just how it looks in general. So we'll go back to our sheet view. If I open up the Explorer tool and go to the bottom, I can see all the different models in here. And what I'm going to do is just simply drag and drop that plan view out here onto the sheet. And then I can move this anywhere I like on the sheet. But I can also quickly see how that looks here in this view. All right, next up here is how do we go about creating a bar schedule of all of this reinforcement? So let's take a look at that. So here I'm running OpenBridge Modeler, but I've enabled a full ProStructures license here. So again, I didn't have to go out and separately install ProStructures to be able to do this. I'm just in the structural detailing workflow. I've brought up the drawing information window first. So these are a bunch of predefined fields that you can go in and utilize for your bar chart and schedule generation. So here I'm going to go to the reporting tab, go to the concrete reports here, and I'm going to ask it to create a part list database here. So it's going to create an access database of all this reinforcement. I'm going to ask it to choose all the bars here in my model, and it will add those bars and all of their attributes to a set of tables in the database there. And then I can see a list of all that reinforcement, and then I can go out here and generate that chart. So I'm just going to do a quick preview of several different bar charts that are available to you that get delivered with the software. So go out and select a list file here, and then go back to the print preview window, and you can see a variety of the different output reports that are available to you. So if you wanted or needed to include either your sketches with dimensions or labels or both, all of those can be shown here with all the dimensions and labels in your bar chart or in your schedule. But there's a lot of different options here to choose from for generating these various bar bending schedules. So here's one with the dimensions only, and then all of the values listed out to the side for those particular dimensions. We'll look at one more here. And quite a few different options available to you here for bar bending schedules, but you can also define the table yourself. You can add columns to it, take away columns, put them in any order you like, and make it your own. Add your company logo to the top. And again, like I said, there's a lot of different fields that we filled out there initially that go into and can be used when you go about creating your own schedule. All right, so let's take a look at the schedule generator tool. So this is also on the concrete drawing production tab. There's a relatively new schedule generator tool here that's quite powerful. So again, first step is let's load in all the reinforcement that we want to use for the schedule. And it gives you the option of either the original marks that were created during the positioning process, or we can use the user marks where you've gone in and overridden any of those potential bar marks there. And then you tell the software what columns do you want to add to this schedule. You can drag and move any of those columns around, change the width of them, change the size of them. We can sort by any of these fields up here as well, and go through and sort the table by bar size and length, or bar size and bar mark, or some sequence number. And take a look at the resulting changes there. For varied bars, you can show the first and last, or you can ask it to list all the bars in those variable sets. You can set an insertion point for this. You define a text style that you want to use. So here I'm going to go out and select a text style that's in my library and activate it. Once it's activated, basically it's copied into this file, and I can select it and use it in the generation of the schedule here in a moment. You can ask it to exclude any empty columns, for example. If there's certain dimensions that weren't used in the bars, no reason to probably include those in the schedule there. So once you get this set up the way you think you might want, we can go about placing this out here in the file. You do have the ability to summarize columns here and edit those summary headings. But again, once you're ready to place it, I'm going to go ahead and place this onto that sheet that I created previously. So I'll come out here until I want to place a new table and select it. When I zoom in, we'll be able to see, and this is being placed as a true table here within the software, something that's editable at a later time. So again, you can change any options here, come back and place that table out here, and I'll notice that, well, I'd like to have my columns a little wider here, so I'm going to go back and change my default row height and column width there so that it can fit all my dimensions a little better. That's maybe a little wide, but again, all these things are very easy to see as you go back and forth and try different values prior to placement here in the sheet model. And again, once you select it, you'll see all the typical handles and controls that you're used to having with a table here in the software. With that, I want to thank everyone for attending this session and watching what some of the basic tools are that you have available. While I call them basic, they're certainly very powerful tools as well for modeling reinforcement on your structure today within the OpenBridge software. Thank you for attending.